So I'm going to start by talking a little bit about the two things that together make up the final for this class. So one being the reflection assignment, and I know we've talked a little bit about that, but that is due at the same time as the final. And for the final exam, currently I have last year's final up on the assignment just so that you can kind of use that as a practice final. I will post the actual problems for the final exam at 12:01 on the day that your final is technically, or final is scheduled to be from 1 to 3, but you can finish it anytime during that day before 3 p.m. If you would prefer to actually sit and take a final in person, I will physically be in this room. So I will be in the room from 1 to 3. You're welcome to come and take the final in this room if you would rather, and then not worry about having to submit it to Canvas. You can just, I will print out copies of the final and bring them, and you can take it on paper and hand it over to me and walk away and be done. If you would rather take it earlier in the day and then submit it through Canvas, that's totally fine. So the actual final exam will be about double a quiz. You have obviously more than 2 hours to work on it if you choose to start it at home. If you come to sit for the final, then you'll have 2 hours to work on it. It shouldn't take you 2 hours, but you certainly have that time. And for anyone that has testing accommodations to have extra time, since I'm going to release it at midnight, you'll have plenty of time that morning. But if you have other finals that morning and it's not going to work for you, please just send me an email so we can work something out. But otherwise, I'm not presenting any more new material. So today and Friday are both kind of review days. And I wanted to start by opening it up. Are there any questions from any past quizzes or homework assignments that you all would like me specifically to go over? And I'll wait for a second in case anybody wants to pop anything into the chat. Otherwise, we can definitely get more practice with completing the square for sure. And otherwise, my plan was that I would actually spend the time working through last year's final, so that because that'll kind of review all of the topics. So maybe I'll just, oh, yep.
Sorry. I actually wanted to know, when is it that you try to find the kids? So I know for some of them, you can just put on Desmos and it's really graph, but then there's other times where you have to
Okay, so that's a good question. Like, how do you know when you have to solve for the vertex for a parabola to complete the square to put it in that vertex form or not? So here's what I would say when we're thinking about parabolas. There are kind of 3 forms that the equation for a parabola might present itself. So if we're presented with something that's already factored, then personally, what I would do is to graph the x-intercepts and know that the vertex is the midpoint of the 2 intercepts. If I'm given something that looks like y equals x squared plus 6x minus 1. So it's not factored and it doesn't factor. Get my pen working. So this is not factored. I really would like to use this color. Here we go. So it's not factored. And it does not factor. This is when I'm thinking about completing the square. And if I'm going to complete the square, well, we might as well just do it for this one. So if I'm completing the square, I'm going to take half of that coefficient on x. So half of 6 is going to give me 3. So I'd have y is equal to x squared plus 6x plus, I'll take that 3 and square it, add it in, and subtract it back off. This part would then become x plus 3 whole thing squared. And then the back I can combine to say -10. So I would say for me personally, I find factoring to be, I don't know, easier or something that I've just practiced more. So for me, if I can factor it, I'm going to go this route. I'm going to find the x-intercepts and know that the vertex is the midpoint of those 2 intercepts. But if it's given to me in a way that's not factored and doesn't factor, then I'm going to complete the square. I don't know if that answered your question. So here, my 2 x-intercepts are going to come from what makes each of these 0. So my intercepts would be 1 and 5. So I know the x value of the vertex would be halfway between 1 and 5. And I would find that by doing 1 plus 5 divided by 2. The other time that you're probably going to want to complete the square is if there aren't any x-intercepts. So we could have a parabola that, just thinking about what some of the graphs could look like, right? Maybe I have a parabola that looks like this. Well, that won't have any x-intercepts. I might also have a parabola that looks like this, and that has no x-intercepts. And by the way, for both of these, it would mean that they came from an equation that didn't factor. Because if it factors, I know that I'm going to end up with 2 intercepts, or potentially 1 intercept if it factors as a perfect square already. And there is a request to do one of the problems from the homework, so let me pull it up. So question 23. Oh, right. So 23 is the one with triangles. And we had a triangle where we were told that both of these sides were 5 inches, and the bottom is 8 inches. And we're asked to find the height. In general, if we have triangles, we know way more about triangles with right angles. We know way more about right triangles than just triangles in general. So in this case, I would split the triangle in half to form a right triangle down here. And because I split the base in half, it's no longer 8 inches. If I just focus on this triangle right here, this side would be 4 inches. And the height is what we were trying to find. And I can use Pythagorean theorem now on this smaller triangle. So I would say that 4 squared plus h squared is equal to 5 squared, or 16 plus h squared is 25, which means h squared, if I subtract 16 from both sides, would be 9. And I would technically get that the height would be plus or minus 3, but then we use our logic. I can't have a negative height for a triangle, so our height is 3 inches. Are there other specific questions anybody would like to go over? This homework, previous homeworks, previous quizzes? If not, I'm gonna switch gears and start working through the problems from last year's final. If anything comes up, go ahead and drop it in the chat or let me know. So this, if you're looking for this actual PDF, it's under assignments. If you click on the final exam, currently what's in there is last year's final. So if you look at that, that's what I'm working through right now, is the 2020 fall Math B final exam. And I don't think we're going to get through all of it today, but we got Friday also. So problem 1 has my least favorite instructions, but it just says simplify. And what we've got here is 7 squared times 2 minus 9 squared times 3. So if we go back to the first week of the quarter, we kind of started off with order of operations and additive law of exponents. So order of operations, just as a reminder, the acronym that sometimes we think about is Pemdas, which means if we have parentheses and we're able to simplify what's inside of parentheses, we should do that first. Then we should look at exponents, then multiplication and division, then addition and subtraction. So looking at this, I do have exponents, so that's what I should work with first. 7 squared is going to be 7 times 7, or 49. So I'm going to have 49 times 2 minus 9 squared is 81. So 81 times 3. I've mentioned this before. I am totally fine if you want to use a calculator. You won't be able to use a calculator for pre-calculus or calculus. So it's kind of up to you, but I don't want you to get stuck in a problem just because of the numbers. If I were doing this, the way that I would actually multiply 49 by 2 is I would say, well, 50 times 2 is 100. 49 is 1 less than that. That's going to be 98. (81 times 3) if I were doing this, I would probably think about, well, 80 times 3 is 240. And 1 times 3 is 3. So this is going to be 243. That's not pretty to do 98 minus 243, right? But the skill that really we're working with here is number sense and use of numbers. Because I have a smaller number subtracting a larger number, I know that the final answer is going to end up being negative. And then if you want to use the subtraction sort of algorithm, I would take that 243 and subtract 98. Now we know that that's backwards from what the question is, but I already know that my final result is going to be a negative number. So I've kind of already taken care of that piece of it. And 243 minus 98, if we wanted to use that subtraction algorithm, we can borrow 1 from the 4. 13 minus 8, I get 5, and 23 minus 9. Or if you want, you can borrow 1 from the 2, make that a 1, make that a 13. 13 minus 9 is 4. So I'm going to end up with 145, but I need to make sure that that is negative. Good times. Question. Yep. So there's a difference between writing, if I write -9 squared versus -9 squared. This notation wise means that the thing I'm multiplying by itself is -9. This means I'm doing -9 times another -9. Notation wise, this means that the only thing that's multiplied by itself is the 9. This is a minus 9 times 9. It's subtle, but that's a notation thing. Yeah. Another one of those week 1 sorts of skills was prime factoring of numbers. And this really what the prime factoring of numbers was doing was it was kind of getting us ready for finding lowest common denominators when we were dealing with fractions. So when I'm thinking about prime factoring of a number, just a couple of tips sort of. I don't know if y'all know this trick. I don't know whether we talked about it. I know that this is divisible by 5 because it ends in a 5. But I also know it's divisible by 3 because the sum of the digits is a multiple of 3. Just kind of a fun thing. So if I add up those digits, 1 plus 0 plus 5, I get 6, and 6 is a multiple of 3. So I happen to know that this must be divisible by 3 and also by 5. From there, I'm probably going to pick the 5 because it's going to make this number smaller or faster. So if I'm thinking about this, this has to be 5 times something. 5 times 20 would be 100, which means 5 times 21 should be 105. If your brain doesn't logic through it like that, you can always use the long division algorithm. So once I know that it's divisible by 5, I can take that 105 and think about, okay, 5 times what gives me 10? That's 2. When I multiply that down, that's a 10. 10 minus 10 is 0, and I bring down the 5. And 5 times 1 gives me 5. Then we can break that down further. So the 5 is already a prime number, but 21 is 3 times 7. So my prime factorization, or the factors here, are 5, 3, and 7. Pausing for questions for a second. Or we can do another example of any of these if you want another example. Yep.
Is it kind of just like up to us kind of figure out what's the biggest number to think about it like this? Or like when we eventually get there? That's what I'm kind of worried about, like.
So in terms of, so the final answer needs to be the smallest numbers that you can possibly break it down to. How you get there doesn't matter. So let's say that you had used the trick and knew that this was divisible by 3. Well, if we had started with that, then we would have ended up taking that 105 and dividing by 3. So I would say 3 goes into 10 3 times. 3 times 3 is 9. And when I subtract, I'd get 1 and then bring down that 5. So then 3 would go into 15 5 times. So if we had done this, we'd have that 105, 5, not 2. And I'd have 3 times 35. But to get it to the prime factors, I still need to break down that 35. But 35 is 5 times 7. So we would end up with the same 3, 5, and 7. Yeah, so it shouldn't matter. Or like maybe you knew that 105 was divisible by 15. That works too. However you choose to get started will work. Let's see. So our next one here, we're going to be solving, and I've got 9x minus 7 is equal to 11x minus 9. So this is a linear equation. It's an equation because I have an equal sign, and it's linear because the powers on x are equal to 1. This is really just a group like terms on one side of the equation, group my numbers on the other side of the equation. So I would probably personally choose to subtract the 9x from both sides, because I always like the coefficient on my x to be positive. You don't have to make that choice. That's just the choice I would make. And then I would end up adding 9 to both sides, so that I've got 2 is equal to 2x, and x must be equal to 1. Gonna flip the page unless there are questions on that one. Problem 4, we've got some parentheses here. So we're thinking about kind of our order of operations and distributing things. And we also have an inequality. So when we solve this, when we were doing this back in chapter 3, maybe, when we solve these, we had a couple of different ways that we can write the answer. So we'll go through all of those 3 ways, but the first thing we want to do is just to isolate the x by itself. So we have two choices for how to start. Because I have parentheses, we can either distribute that 3 in, or we can divide both sides by 3. Personally, I wouldn't divide both sides by 3 because I like to avoid fractions as long as I can in a problem. So I would choose to distribute this 3 in. So I would have -9 plus 9x is greater than or equal to 2. Add 9 to both sides so that 9x is greater than or equal to 11. And x is greater than or equal to 11 over 9. Now I mentioned that we had different ways that we could write our answers. One of the things that we did was to graph that solution. And graphing the solution means that I have a number line and I put 11 over 9 on it. And then I would shade in the side where the numbers are bigger than 11 over 9. So I would shade in on this side. And we can either have a filled in circle or a square bracket, because this answer should include the 11 over 9. Another form that we can write our answer in is interval notation and say that the values of x that make this true are any numbers between 11 over 9 and positive infinity. We have the brackets on that because of the or equal to, and infinity always gets parentheses because it's not a number that we can actually arrive at. Question? Yeah. So you fill in the dot because it says or equal to, right? If I didn't have that bottom bar and it was just greater than, then we would have an open circle instead of a closed one. The next thing we kind of moved into back in chapter 3 was some graphing. And back then we graphed points and lines. So if I look at question 5, I've asked you to graph a bunch of points on the same coordinate plane. And so just some reminders when we are graphing. So anytime we have been given coordinates like this, X comes before Y in the alphabet and X comes before Y in the points. It's always X before Y. By convention, we call this the x-axis, and we call this the y-axis. The positive x values are on the right-hand side, the negative x values are on the left, the positive y values are at the top, and the negative y values are at the bottom. So if I go to graph the point 2, 1, that means to go over 2 in the x direction and up 1 in the y direction. 0, 3 means that my x coordinate should remain 0. I shouldn't move off of 0, but I should go up 1, 2, 3. -2, 1 says move 1 to the left on the x-axis. And this is our origin. So everything is always like in reference back to our origin point. So if that's a -1, 2, I'm taking 1 step to the left to be at a -1 and then up 2, 1, 2. Last, I've got 4, -3, so that's 4 steps out in the x direction and then down 1, 2, 3. So 4, -3. Notice these points don't like form a line or anything. They're just random points on the plane. Just as a reminder from like when we were doing this stuff, we call these the 4 quadrants. This is quadrant 1, where all of the X and Y values are all positive. This is quadrant 2, quadrant 3, and quadrant 4. And I don't know why, but when we talk about the quadrants on the plane, we often use Roman numerals. Question 6 asks us to graph the equation y equals -2x minus 1. All we really need for graphing a line is 2 points. I don't mind at all if you want to, because this is in the slope intercept form, you can definitely just use the intercept and then the slope to get those 2 points. Or you could find the X and Y intercepts. It doesn't matter to me. It's totally up to you. So just looking at this, I know that my slope is equal to -2. And my y-intercept is 0, -1. So if I used the slope and the intercept to sketch my graph, sorry, I gotta move it up a little bit. If I use the slope and the intercept to sketch the graph, then I would start at that intercept of 0, -1. Not label it over here. Start with my intercept of 0, -1, and then make sure that I have a slope of -2. Now, a slope of -2 says this is really like -2 over 1, which means down 2 over 1. So I'd go down 2 over 1 and draw my line in. Now I want to see 2 points labeled on the graph. I don't care which 2 points, but if we're going to use the slope and the intercept, then going down 2 means I went from -1 to -3, and over 1 means I went from 0 to 1. Alternately, if you wanted to just find the X and Y intercepts, you could. The Y-intercept we already have, and we'll get the X-intercept by setting y equal to 0. If I do that, I'd have 0 is equal to -2x minus 1. Add 1 to both sides. Divide both sides by -2, and I would get that x is equal to -1/2. So my intercept is at -1/2, 0. And it'd be totally fine to sketch that point instead, -1/2, 0. So we take a look now at the next problem on here. Question 7. says, let 3x minus 5y be equal to 3. Find x if y is equal to 3. This is also a linear equation. It's one of our other forms. This form for a linear equation is called our standard form, even though it's not the one that we use the most, but it's called the standard form. So this question is saying x is equal to what when y is equal to 3. So in this equation, I'm going to replace y with the number 3. And I will have 3x minus 5 times 3 is equal to 3. Or 3x minus 15 is equal to 3. So I can add 15 to both sides. And have 3x is equal to 18 or x is equal to 6. So I know that the point 6, 3 is on the line. The question only asked me for the x value, so that is the answer, but that means that the coordinate of 6, 3, or the ordered pair of 6, 3 is a solution to this equation and a point on the graph. On question 8, I have given us a graph. And this is what that line looks like. And I have labeled this -2, and I have labeled this -1. And I'm asking for the slope and the x-intercept. Well, I have been nice and labeled both of these. Well, no, I've labeled one of these on the graph for us. So I've asked for the x-intercept, which means we're looking for the point on the x-axis where the line crosses. So my x-intercept is right here. And if I label that as a point, then my x-intercept is the point -1, 0. In terms of the slope, slope is my change in y over my change in x. So one option for how to find the slope is like y2 minus y1 over x2 minus x1. Because I have these two nice points on the graph, I can definitely use those if I write them as their coordinates. So that -2, but on the y-axis means this is the point 0, -2. And that -1, we already said, is the point -1, 0. So if I use the equation for the slope, this would look like -2 minus 0 divided by 0 minus -1. And I would have -2 divided by +1 or -2. Thinking back to the quiz on this, I know that a lot of folks were a little bit uncomfortable when the slope came out to just be a number, and we kind of wanted to see it as a change in y over a change in x. Either of these is totally acceptable. These are both correct. So if you like it better to see it as a change in y over a change in x, it's totally fine to write that as that fraction. And I'm keeping an eye on the chat. I haven't seen questions in the chat, so I'm kind of just keeping going. But you can slow me down at any time. Problem 9, we have been asked to find the equation of the line that passes through points 1, 1 and 4, -3. I mentioned that there are 3 different forms for the equation of a line, and while it doesn't matter which one you use, I will say that as we are moving towards calculus, the equation for a line that we end up using the most in calculus is y minus y1 equals m times x minus x1. And this is called the point slope form. Its name kind of says it all, but anytime I'm trying to find the equation of a line, there are 2 things that I need to know. I need to know a point and I need to know the slope. Well, in this case, I've been given 2 points and we can use either one to plug into this equation. I'm going to choose to plug in 1, 1, which means my equation would look like y minus 1 is equal to m times x minus 1. You could have also chosen the 4, -3, and that would be totally fine. So this would look like y minus -3 is equal to m times x minus 4. But for either one, we're going to need to actually compute the slope. So I'm going back to that y2 minus y1 over x2 minus x1. So if I'm doing that change in y, I'd have -3 minus 1 over my change in x, 4 minus 1. On top, -3 minus 1 is going to leave me with -4. And on the bottom, 4 minus 1 is +3. So for a final answer, I could either write y minus 1 is equal to -4/3 of x minus 1, or y plus 3 is equal to I said 4/3, I wrote 1/4. I know I said 4/3. I just wrote strange things. Or -4/3 of x minus 4. If you really, really, really hate this form, you can go with y equals mx plus b. You'll just do more work. So my recommendation is don't do more work. After we finished up the section on lines, that's when we got into the chapter with all the exponent rules. And if there are 3 things that I would hope you would walk away with this quarter, it would be being comfortable writing equations of lines, being able to solve a quadratic equation, and being able to simplify exponents. Those are kind of like 3 super critical things that we're going to use over and over again moving forward in your classes. So let's pause from working on this to do a quick review of some exponent rules. And I know I've written out the additive law of exponents a bunch of times, so I'm not going to make us go back there, but Do review it if you're feeling uncomfortable about additive law of exponents stuff. Because that's really where all of our rules are based in. So if I have a number like 5 raised to the 0 power, that's always going to be equal to what? Yes, this is 1. 5 to the 0 is 1. 17 to the 0 is 1. Negative 29 raised to the 0 power is 1, right? A number to the 0 power is going to be 1. If I write 5 cubed, that means that I have 5 times 5 times 5. And because of that, if I have 5 cubed times 5 to the 4th, this one says I've got 3 5s multiplied together. This one says I have 4 5s multiplied together. And in total, that means I have 5 to the 3 plus 4, or 5 to the 7th power. And that's our additive law of exponents. So when I multiply two things that have the same base, I add the exponents together. If I have something like 5 cubed squared, this means that I have 5 to the 3rd times another 5 to the 3rd. And our shorthand for this would be to say that I have 5 to the 3 times 2, or 5 to the 6th power. So when I have a power raised to another power, that's when I'm going to multiply those exponents. 5 to the negative 2 power, that negative means that this is a fraction, and this should really be 1 over 5 squared. Similarly, if I had something that looked like 1 over 5 to the 4th power, I can rewrite this as 5 to the negative 4. And there are times when it's going to be important that we can go back and forth between those two things. By the way, if I had 1 over 5 to the negative 4th, this would become 5 to the positive 4th. If I had 5 to the 6th divided by 5 squared, I could write out the top as 5 times 5 times 5, 6 5s multiplied together, and the bottom would be 2 5s multiplied together, and 2 sets of those would cancel out. The shortcut way to get there is to say that because I'm dividing two things with the same base, this becomes 5 to the 6 minus 2, or 5 to the 4th. I am out of time for today. My plan for Friday is that we will work through the rest of the practice test. But if there are other things that you all want to work on Friday, that's totally fine too. Come with your questions. And I hope studying for your other finals is going really well too.